Hi, I'm Sam Roberts from Roberts Geospatial Engineering. Today I want to do a deep dive into how to import LiDAR data into ProRaster Scientific. So on screen I'm displaying a LiDAR dataset. It's a point cloud dataset, it's a 2D point cloud dataset. And as I zoom in, we go in and in and in, and we see lots and lots of LiDAR returns. Each of these individual dots is a return in the LiDAR survey. So this is stored in an MRP file. It's a file with an MRP extension. And the only way to work with point cloud data, whether it's LiDAR or multi-banded general point cloud data, in ProRaster Scientific is to create an MRP file. So we're going to import all of our LiDAR data from LAZ files or LAZ files into an MRP file, and then we'll work with that MRP file in ProRaster. So this particular survey, as an example, contains about 10 billion returns. And this is a bathymetry survey. In fact, it was designed to measure bathymetry, and so it's mainly offshore. You can see that these brown returns are the land, and then these returns offshore are bathymetry returns. For example, these are sand, these blue ones are water. And if you zoom in, you can come in and turn on tooltips and see exactly what these returns are. So, for example, these white returns are non-seabird. So that's usually a reflection, I think, from the surface of the water, or it might be a fish. Whereas these other ones are seabed reef, and they're the returns we're looking for. They actually have a bathymetry value, minus 0.25 meters there. And then as we zoom out, you'll see that those non-bathymetry returns drop out as I zoom out. Now that's not an accident, that's by design, and that's part of the import process. We're keeping the returns that are of value and of interest to us, and preferentially throwing away returns that are of no value and of no interest to us. So we're going to see how to do that in the LiDAR import process. Now what we do with this data once we've got it is that we can visualize it, and we can also grid it in real time. So if I go down here to my point processing menu, open this virtual gridding operation, hit OK, and here we have that data set gridded in real time. I'll just change the color scale so it makes sense. So as I zoom in, those points that we were looking at are now being gridded in real time. In this case, we're using triangulation. You can see the triangles, and so we're gridding 10 billion points in real time, and we can explore the data using this technique, and do QA and so forth. So, for example, out here in the bathymetry, this is a shipwreck. That stands out. And this is onshore data. This is all ground returns. And out here we have bomboras and various features in the bathymetry. So that's what we're aiming to do. The first thing we have to do is import all of our LAS data and LAZ data into an MRP file in order to be able to achieve that. So let's go to our point processing menu, import LiDAR, and move over to the right. At the top there is an import LiDAR option that will open the importing dialog, and then below it are all of the import operations that you've already executed. And you can go back to those operations to either run them again and repeat them, or you can go back and add more data to an MRP file using all the same settings by going back into one of those operations. So we'll see how to do that. But let's start with a fresh import. So here's the import dialog. The first thing we need to do is to specify the LAS or LAZ files that we want to import. So you can browse for individual LAS files. So I go up to here, data, LAZ, demo. So here I have some LAZ files, so I can browse for individual files and select them. Or you can add a folder and take all of the LAS files or LAZ files from that folder. So specify which ones you're interested in. Go to that folder, which it's lost again. Select the folder, and now it's selected all of the LAZ files from that folder. So there's a couple of ways to select data files there. Hit the negative button and you can clear it. So let's start off by just selecting a few files. So I'll just select the first 4, hit open, and those files come into my list. Now I have to specify my output file name for the MRP file. So let's go into here and I'll just do demo. The temporal storage mode, we're going to come back to that. There's a few options here, but for now we're going to accumulate all those points into a single event. I'll explain that later. Now the MRP file itself can have some properties. Firstly, it can have a cosmetic name. So this is this is Central Coast Marine LiDAR. And then when you load that MRP file, that name will come up as the name of the file. It can also store some metadata, and this metadata can be in XML, or it can be in any text file format. So I can take any text file and just add that in as metadata to the MRP. So that will be stored in the MRP. And then when you go into ProRaster and you look at the properties of that file, you'll be able to see that information. So if you have a technical report that's in XML format or in any text format, all about the survey, all of the parameters, the classifications, and all those details, they can all get stored into the MRP. That can get stored in the MRP file and kept for all time, and people will always be able to go and see that information just by looking at the MRP file in ProRaster. So I'll turn that off for the time being. We don't want that. Now, next we need to define the coordinate system. So just some information on this. Firstly, you can see that in this case, it's already defined a coordinate system. So this is the coordinate system of the data here. And it's already selected and defined one. That means it has acquired the coordinate system from the LAZ files that you've selected. So LAS files and LAZ files do store coordinate system information, but it can be a bit dicey. Old ones in particular can be hard to interpret, and they may not be in any particularly useful format. So it can't always identify what the coordinate system of the LiDAR data is, and sometimes you'll have to specify it manually. To do that, you'll just hit the Projection Explorer button, search through here for the coordinate system that you want, or go to the part of the world that you want and double click, and it'll give you some suggested coordinate systems. Say here for Reunion, and you can select that coordinate system. If you don't know where the data is, but and you're not getting coordinate system information automatically from the LAS files, you can run the import, and it will give you a report as it's running. And if it finds information in the LAS file about the coordinate system, it will report it onto the screen. And that might give you some clues as to what the coordinate system is, when the system itself can't can't decode that information. But there's text information that's stored in these files. It may not be in any useful format, but you might be able to look at it and get some useful information from it and determine what the coordinate system is. Now, all of the coordinate data from all of the LAS and LAZ files that you import is expected to be in that coordinate system. So we're not going to do any kind of reprojection of any data as it comes in. We expect all of that data to be in that specified coordinate system. Now with LiDAR data, of course, the primary information is the Z channel, gives you your height above or below sea level. By default, it's going to be in meters. Some data, for example, from the US, will be in feet. But generally speaking, we don't make any assumption about that. And if it is going to be in feet, you're going to have to set that manually. So come in here and tick on vertical units and set it to whatever you think the vertical units actually are. And that doesn't actually change anything. It's not going to do any kind of conversion or anything when it imports it. It just records it in the MRP file as the unit. And that can then be used later when you're doing things like drawing profiles, for example. That can be used, but really it's just for information for the future. So that's our vertical units. And then finally, you need to set a cell size. What has a cell size got to do with point cloud data? Well, the MRP format is very much like the MRR raster format. In that, data is stored into tiles, and those tiles have a specific size, and that's defined by the number of cells in the tile and the size of the cell. And for an MRP file, all tiles are 256 by 256 cells, and the cells have some kind of size. Your goal is to ensure that you get about one return per cell. So you need to set a cell size that is approximately, that'll give you a return density of about, 1 per cell. And the default is 1. So in this case, it'd be 1 meter by 1 meter. For LiDAR data, often it's better to go a little bit smaller, so 0.5 or even 0.25 meters. And once you go fractional, it's a good idea to actually specify your cell size as a fraction. So I can specify it as 1/4 for the X and Y cell size. And you can see that it reflects that here as a decimal of 0.25. ProRaster works with fractional mathematics internally with large rasters and large point datasets. And for very large datasets, that results in better accuracy and less floating point round off. So it's a good idea to use fractional cell sizes when you can. So that's our cell size. Now, how do you know that you've got the right cell size? If your cell size is too large, then you're going to have a large number of points in each tile. That means that your performance when rendering and when working with that data is going to be reduced. So you want to avoid that. On the other hand, if you make the cell size too small, then the file will get larger and it will get less efficient. You'll be loading lots and lots of tiles in order to acquire data over the area that you need. So you do want to hit that sweet spot. So it's a good idea to run an import on just maybe one LAZ file and then look at the statistics of that file. And that can give you some information about the point density and whether or not you've made a good choice on the cell size. And so I'll show you how to do that after we've done our import. And then finally down here, we have this setting, do not propagate classes into overview levels. And by default, it doesn't propagate classes 0, 1, 7, 12, and 18. So an MRP file stores all the data in tiles, and then it creates an overview pyramid. And each level of the pyramid, the tiles are twice as big as they are below, and the number of points in each tile is reduced by a factor of 4. And as we build that pyramid, we don't want to throw away good returns that have interesting data and keep returns that are of no interest to us. Because in LiDAR data, the returns that are of no interest usually vastly outnumber the returns that are of interest. So we want to propagate those returns that are of interest and throw away returns that are not of interest before we start throwing away returns that actually interest us as you build up that pyramid. So for example, here's the classification table. So we're throwing away 0 and 1, so that's never classified and unassigned, 7, which is noise, 12, which is overlap, and 18, which is high noise. So we throw those ones away preferentially by default. You can add into this list any other return classifications that you want. And for example, with the marine LiDAR, I also added into this list the bathymetric returns that weren't actually coming from the seabed. So they were coming from fish or from reflections or from seaweed. I also threw those ones out preferentially because those returns are of no value to me in that data set. That doesn't mean they're not stored in the MRP. They'll be in the base level, and they may propagate up the pyramid some way, but we've got to throw some returns out as we go up the pyramid, and those ones will go first. So that's that setting. So let's hit OK and import some data. So here's our import mechanism. It's reading those 4 LAZ files. It reports how many returns and pulses that it streamed in. And it tells you how many stations it brought in altogether. That's how many returns it brought in. It's computing statistics, and then it's going to build the overview pyramid, which it's doing now. Now, just a note on pulses and returns. So in ProRaster, we are very pernickety about pulses and returns. We keep all the returns associated with a pulse together. So even when we're spatially sorting, we don't split pulses. You won't find returns split across a spatial boundary in the MRP file. We keep the returns from a pulse all together. And that's because when we apply LAZ queries are executed on a pulse. And so you want all those returns associated with that pulse right there where you need it and in order so that you can process those LAZ queries properly. Now, I think that the rest of the industry does not have the same the same sort of attitude towards maintaining nice pulse return data. And so you can see in this report that it says that it's streamed here, you know, X number of returns and X number of pulses, of which this number of pulses had fewer returns than expected. In other words, it's found a pulse. The pulse reports that it has 4 returns, but then in the file, only 3 returns were found. So 1 has disappeared, and that's probably a result of the processing and the generation of these LAZ files by the contractor that did the data. And now I think they've made a mistake. I think they've stuffed up their data, and I don't think it should be like that. And there might be some other reasons why some returns don't have the expected number of pulses. You know, perhaps some pulses don't have the expected number of returns. Maybe some returns have been discarded by the contractor, which I also don't think they should do because that's our job to discard them in real time when we're processing the data, rather than have the contractor discard them. I just think this is interesting. The other possibility is that the data is not ordered correctly in the LAZ file, that the pulses and returns have been mixed up. Well, there's nothing that I can do about that. I can only assume that everything is properly ordered. If it's not properly ordered, then you could possibly sort the returns in the LAZ files so that they are properly ordered. The only way to do that is to sort based on the GPS time of each return. But then on the other hand, you see a lot of data where the GPS time is not recorded correctly, in which case you can't sort based on time. So that's a problem. Anyway, it's something that ProRaster doesn't address. We assume that all the data is properly sorted. We don't give you a mechanism to sort that data, and you're going to have to do that externally if you need to. So we've imported the data. Hit OK, and it will display the points. So they're the points that we've imported. We can go to the color and turn on classification, choose the classification. I have a special classification table for this particular data set because it has some extended classification numbers. So there's all of our points and returns from that import. Now, let's go back and do it all again. So if I go on to the Import LiDAR menu, you can see now that there's a new entry here called Demo. This is the import that we just executed. So I can come in and work with this import again. So you can see up here there's a button that has appeared. It's called Restart. So there are two things that you can do. You can either completely start again and do the import all over again, modifying some of the parameters, or you can edit, or you can add additional data to the MRP file. So let's go through the process and do that. So in the list here, you can see that there's star, 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 star. These are the files that we've already imported. Now I want to import all the LAZ files from the demo folder. So I'll select that folder, and there are 8 files in that folder. And you can see that it's added 4 new files onto the list. It detected that 4 of those files have already been imported and processed, so it won't reprocess those. We're in the process of adding more data to the MRP. So it's just added in those 4 files that haven't already been processed. Let's hit OK and see what happens. Okay, so it tried to do the processing and it gave me an error. The raster is currently open. No concurrent access is allowed. Oops! The MRP file is currently being viewed in ProRaster. So that's no good. I've got to close that down before I can go and edit it. Let's do that again, just quickly. I'm going to select all my LAZ files in the folder. Then I'm going to hit OK. And it's going to add those 4 new LAZ files onto the MRP file. And then it has to do some additional processing. It has to recompute all of the statistics. And it has to rebuild most of the overview pyramid. It won't rebuild the entire pyramid, but those parts of the pyramid that have new data in them, that will have to be reconstructed. So it's just going to go through and do that now. So when that's finished, we'll come back and have a look at the statistics of the MRP file and look at the pulse density and the point density per cell. And that's going to give us an idea of whether or not we've chosen a good cell size. And there are a number of ways to look at the statistics in an MRP file. We can go on to the raster processing menu, or we can go through the raster source editor, and we'll look at both of those. Meantime, we'll just wait for this to finish. I guess I should have chosen slightly smaller files. Just one other note while it's doing this, you'll see that it actually read these files in parallel. I was using multi-threading. If your files are on an SSD, it's going to use multi-threading to import those files. If your files are out on some kind of external hard disk or any hard disk, any actual spinning hard disk, then it will import the files one by one. But on an SSD, because the reading is so quick, it does the whole thing multi-threaded. So I'll shut that down. Okay, there's our point data set. How do we look at the statistics of this thing? Go onto the raster processing menu and go to the statistics analysis dialog. My recent MRP data set is sitting here on the menu, so I'll just select that and hit OK. Now this thing will compute statistics, but because we've already computed them, it just doesn't do anything and brings them straight up. So here's our statistics viewer. So it can tell us the valid number of samples. This is actually the number of returns. So we've got 119 million returns in this data set that we've just created. Various summary statistics about that. There's your spatial statistics, your histogram. So for example, I can go to the classification band and look at the histogram, and that shows us what classes are in this data set. And I can also see that as a spreadsheet. So class 1 has got whatever that is. What's that? 65 million points. His ground classification has 13 million points, and so forth, right down to these extended classifications up here at 21, 22. And here's our bathymetry classifications in here. So you can look at all that information in the histogram. Now, there's a little button here on the summary page, View Statistics Report in your text editor. So I press that and it's going to create a file. And then you can see some additional information. So in here, it'll tell us the cell count and it will tell us the point count. So that's the number of returns that we actually have. It'll also tell us the pulse count. So that's the number of pulses that we have. And you can see there's about half as many pulses as there are returns. And then we can get some statistics about whether cells are occupied or not, and what the density of returns and pulses are in those cells. So here's the number of occupied cells and unoccupied. The global point density, number of points per cell, so that's just below 1. That's for all cells occupied and unoccupied. For the cells that are occupied, the point density is closer to 2. The global pulse density is about 1/2, and the pulse density in occupied cells is closer to 1. So that's pretty good. That's pretty reasonable. That'll give us good performance when we're loading tiles. If it's significantly higher than that, then you might want to decrease the cell size when you do the import. If it's lower than that, then you're going to want to increase the cell size so that there are more points per cell. So that's one way to look at the statistics. Another way, just quickly, is to go into the raster source editor. If you're displaying that file, it will be visible, and you can view statistics here, or you can get an info report that generates a report into a window, And then you can see that same information. So here's our global point density, global cell density, pulse density, and so forth. So that's two ways that you can go and get that information and figure out whether or not you've made the right choices around cell size. Okay, so there's one more thing that I want to talk about. So let's go back into Import LiDAR, perhaps two more things. Go back into Demo. Firstly, if I hit this restart button, then the button disappears immediately and everything becomes active. Now I can just run the whole thing again. The MRP file is going to be replaced by a new MRP file, and you can just do everything from scratch. And you can change then any properties that you want. For example, you can change the cell size. So I won't bother to do that. But next I want to explain what this temporal storage mode means, and what you do with that. So far we've only been accumulating. There's two other modes, accrete and repeat. So let me go to the help menu, go to the ProRaster user guide. And there's some information here. And I'm going to just read this out for you. So accumulate is the most commonly used option. It adds all the new data into the same temporal event as any existing data. So when you're surveying, you might get 10 files on the first day, you'll get 10 files on the next day and 15 files on the third day. You can just keep adding all of those new LAZ files into the same MRP file by accumulating, and at the end of the day you'll get one contiguous data set, and the MRP file will have no memory of the fact that you imported data in like 3 or 4 separate tranches. That it will all just become merged together. On the other hand, you can use the accrete option to remember in the MRP file that you've brought in data in different events or different tranches. So the accrete option adds a new temporal event, a new time point in your MRP file. So MRP files don't just have spatial dimensions, they also have a time dimension. And you can use that time dimension when you're rendering and when you're gridding. So it adds new temporal event each time you add new data to the MRP. That allows you to differentiate between different phases of a survey by time, but you can still treat the survey as if it's one continuous point cloud data set. And I'll show you a little example of that. I'm not actually going to run this as an example, but I'll show you some files. Finally, there's a repeat option. So the repeat option creates a new temporal event each time you import data. The expectation is that the data will overprint the existing data each time. So for example, if you're a mining company, like you're mining coal, for example, and you have you've got all of the coal stored in a facility, and every day you go out there and you fly a LiDAR survey of that stack of coal in order to compute the volume of it mathematically, and to figure out how much coal has come in and how much coal has gone out. In that case, you might use the repeat option. So each survey that you bring in every day is effectively a new survey and a unique survey. So it creates a new temporal event each time you import the data. And then the data in those events won't get combined. So so when you're gridding, you'll be gridding each event individually. So that's the repeat option. So I do have some files that demonstrate that briefly. So let's get out of there now. And just one point on that. once you've started importing, this option will no longer be available. So you have to decide when you begin to build the MRP file how you're going to be adding data into that MRP file, whether it's all data from the same survey and you're just accumulating, whether you want to remember that each tranche of data that you bring in is from a different survey or a different phase of the survey, and therefore you want to keep those events, those temporal events, separated, or whether each is a repeat of a particular survey over a particular region. You have to decide that first. So let's have a look at an accrete example. So this is not LiDAR data, this is just some aeromagnetic data. And you can see that the data for this data set is got a different sort of value range to this one down here. So in this case, we're accreting. So if I open the time control panel, there are two time points. So there's the first time point, which is that particular data set, and then there's the second time point. That's the lower left data set. So you can swap between them. So there's our temporal dimension. But I can come into here, into the component page, and say, well, I want to see all data from the beginning of time to the end of time, and then I can see that data from those two events. And I could grid that data from those two events together, assuming that the data was compatible. So that's an accrete option. Here's a repeat example. It's not a very good example because it's not in the same place. It's the same data sets. So bring up the control panel. There's my first data set, first temporal event. There's my second temporal event. Now, if this was a real example, they'd sort of be in the same place. They'd be different data, but they'd be spatially in the same place. But it doesn't have to be like that. So there's our two events. Now, if I go back in and say I want to see from the beginning of time to the end of time, now I'm only seeing that last time event because they're considered to be replacement events, and they're not combinable. So ProRaster is not letting you combine the data from those events together. It's going to treat them as though they're all completely separate. So that's what happens when you use the repeat option to create a temporal MRP. And just finally, one final thing, your import files are these XML files, and they come onto this list here. As you import more and more data, this list will get long and files will start to drop off of it. If that happens, you can still come back to the file itself. So here it is here's our demo.xml file that we've just been working on, and you can drag and drop it onto the ProRaster dialog, and it will open that file, and you can still edit it as if you've selected it from the menu. So you can do that with your import dialogues, and you can also do that with your virtual gridding dialogues. So that's a very deep dive into ProRaster support for LiDAR data. Just in summary, you take your LAZ files, you import them into an MRP file. That MRP file supports temporal events if you want. And once you have your MRP file, you can explore your data in maps, 2D and 3D, and then you can employ virtual gridding to grid that data in real time and to explore the data as a raster. Thanks for watching.